Cool, so I want to talk to you about error handling and the condition handling system in R. So there's built-in condition handling that I want to talk to you about: message, warning, and error. And then how you can control the output of those. And then checking and stopping for errors, and then capturing errors and handling it. And when I'm saying errors, it doesn't actually have to be errors. R's system for handling errors is actually built on the signal conditioning system that they have, that they put the error system on top of. And the signal conditioning system, and I'm not going to get into the weeds of it today, but allows you to do all kinds of things where you can start and restop your code. So you can have an error occur in one place, a decision on how to fix it up somewhere else in your code, and then restart your code down below. So the built-in conditions are message, warning, and stop. And who here has never used or never heard of any of those? Okay, a couple of you. So message is a simple diagnostic messaging system that it basically acts like print, but it doesn't print to the standard output. It prints to the standard error. And so when you're on your terminal, they look like the same. But if you're capturing the output in one system, they actually go to two different systems. Warning allows you to send warning messages while your code is running, and they can actually get collected up and displayed after the code is finished executing. And then stop is like stop running. And you can display error messages. So if you're using print statements in your R to debug stuff, it's very, very simple to stop doing that. Just replace your print statement with a message statement. So here it's message, adding parameters, blah, 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 and then I do some work, and then I figure out what result I'm going to return back, and I just log that into the messaging system. And then what you can do is you can disable messages when you're running your code, so you don't actually have to go back and remove those error messages, those print statements, because what I used to do is I would put in print statements, I think you get it working, I remove the print statements, and I have to put the print statements back in. Does that sound vaguely familiar to any of you?
Just comment them out.
Just comment them out, but then you know, oh, I fixed it now and I want to remove all those comments. And so what it does is, you'll see down at the bottom there, it says add parameters, and then it pastes the parameters that got passed in. So I'm passing in 1 through 10, the command add on the bottom. So you can simply suppress these messages. So the command I had before was add 1 through 10. Now if I wrap that in suppress messages, what that does is it suppresses those messages from getting printed. And I don't see them anymore. They just disappear. I don't have to comment things out. We have warning messages, and so a warning message is generally used when you're not going to throw an error condition. The system can handle what is being passed in, but you want to warn on it, and maybe that the user is passing in, you know, maybe parameters that are a little iffy, or maybe if you're using the default, and you just want to let them know, like, hey, you didn't specify this value, so I'm going to use this value for you because I need it. And the warning message is slightly different. So the British is coming as a message that is going to print, and now we have two parameters. One is call dot, and call dot says when you print the warning message, we're going to print the call that was made that caused the warning message to be generated. So in this case, I'm calling the function test, so it's going to tell me warning in test. Because you don't know where this warning is actually coming from, right? You have functions calling functions, it's turtles all the way down. So this one, one guy gets the joke. So it lets you know, like, hey, in this function, this is where the warning was happening. And you can also pass in immediate dot. And immediate dot changes the default behavior, meaning print the warning when the code actually gets executed. The default behavior is to save up all your warnings, and when your code is finished terminating, it prints out the first 50. So there's some ways that we can control the warning output. So the error messaging system heavily uses the options that you can set in R. So the get option and option something equals will control the values that you're going to have. So if you use warnings equals 0, then it prints the top level function is completed, and that's the default. If you want to completely suppress all your warnings, you pass in a -1, that type of thing. You can also control the message length. So by default, it will print out the first 1,000 characters of a warning message, which is like way too long generally. So you can go anywhere from 1,000 to a little over 8,000 characters. That's per warning message. So I usually set this at 100. My warning messages usually aren't that long. You can also set the number of warnings. So who here has seen the message where you run some code and it says, here are your first 50 warnings. If you want to see the rest of the warnings, type warnings. Right. So the end warning option, you can set that to be whatever you want. So I never look at 50 warnings. So I usually set it to like 10. I'll look at the first 10 warnings. Because usually after that one, I'm not that interested in looking at it. Usually the
They're usually repetitive.
They're usually repetitive or something like that.
Seen one, you've seen them all.
You can also check to see if your code actually threw a warning. So if you get option warn and it returns back a 0, that means that there was no warnings. There's actually this warning buffer that collects up all the messages. So you can just grab that and see if your code anywhere along has actually generated a warning. So you may be in your function and you want to check if the calling functions have generated warnings, right? You generally wouldn't have access to that information. So this is handy. If you're having difficulty debugging something that's a little strange and weird, you can check in your code and say like, oh, I'm getting warnings from something else. Something I'm assuming is probably not right, and maybe that my code is fine. When warnings are in the buffer, there is a variable called last.warnings that's created, and that's a named list, and it has all the warnings in it. It's an undocumented feature, so it may still be subject to change, but it's been around for the last 6 or 7 years that I've been using R, so I don't think it's going anywhere too quickly. So you can grab those and parse through them and look for stuff while your code is still running, or if you like you can do a debugging mode, you can read the warnings. You can also, this is really cool, you can run code when a warning event occurs. You can run some arbitrary code. So what I have here is options warning expression equals, and I'm just getting it to do something stupid. I'm just getting it to print out the directory that I was in, right? So whenever warning is called, it will run this arbitrary code for you. So it's good for logging, or if you want to turn on a trace operation at that time. So it's not your code, you don't know where the warning is coming from, you just set this turn on trace callback, and that will stop your code, and now you'll be in debugging mode, and you can go back and see exactly where that warning occurred. We can also suppress warnings, just like we can suppress messages by suppress warnings. And this is handy if you have, like, the tidyverse is slightly annoying. When you load the tidyverse, it will tell you that certain functions are being overridden by other functions. I just wrap loading tidyverse into suppress warnings because I don't want to see that every time, because the default behavior is for it to show you. So here I'm running the code, I'm running test, which should be printing a warning around the British are coming, and what you end up seeing is that nothing is printed to the screen, nothing goes to standard error, and there is nothing in the warnings buffer either, so it completely turns that off. It just doesn't suppress the printing, it suppresses the fact that that warning ever got called.
John, will that do it in functions that you call within that test function?
Yes.
Okay. So the whole stack.
It does it for the whole stack unless there is an error handler somewhere in the stack. The error message is not called error, because that would make sense. So it's called stop. So message is message, warning is warning, and error is stop. And stop has a slightly different interface. So remember, message, just you passed it a text string. Warning, you passed it a text string. You had an arbitrary call, and you had an arbitrary immediate. In stop, you just have the call. And just like in warning, the call will tell you what call was made that caused the stop message to be run. So if I run this here, I call test, all the test does is it calls stop, and it says error in test in the name of love or whatever. So it prints out the error message, but it tells me where it occurred. It also causes your program to halt, but there's tricks you can do to override that. There's a method called get error message, which is good. So how many times have you gotten an error message, you start doing stuff on the command line, and then you're like, ah, crap, what was the error message again? You can just call get error message, and it will return back to you the last error message. So it does one slightly annoying thing, and it appends a new line to the end, which isn't normally there, but for some reason it gets added in. A really handy function is stop if not. So there is no stop if, there's just a stop if not. So the stop if not basically takes logical expressions and will produce an error condition if something is, if any condition is false. And no message is returned that you control. It basically hands back what conditions you're testing. So it's not a very user-friendly. So the user would get back some message like stop if not, and then blah, 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 whatever tests you have inside of that, which is not terribly helpful for the user. And it's basically a concatenation of a bunch of different things. So I have stop if not A, B, and so the operations on that is any is NA A or not all A. So those are the things that it's checking for. It's just not doing a straight logical check. So it's checking to see if anything is NA, and then checking to see if all of it, if something's not all. And then you can just concatenate by a comma separation whatever lists you want to have. And null is treated as true. So null will cause the operation to stop. So here's a short example. We have a function called sum, and it's going to take a vector of integers, and I want to make sure that you're passing into me just integers. You're not doing anything else. So I'm going to strictly type my data, which R doesn't like to do, but I'm going to force it anyways. So stop if not is an integer. The length is greater than 0, right? So don't hand me in an empty integer list because I don't know how to handle that because I can't sum that. Error if is null, or if there's not a number in that because I can't sum not numbers. And if it passes that, then I just call sum and return back an integer.
So you did the bang to not the is null because it doesn't have the positive.
Correct. Peter?
I think the advantage would be rather than doing like an if statement, and then within the if statement having to stop. Is this more efficient, you think, or cleaner, or?
It's a little cleaner because your if statement would have to check for any is NA and not all. So it's wrapping it into one. So where I have stop A, B, you would have to have all of that along the bottom to have the equivalent.
So why is null treated as true stop anything? Because every other true is not stopping it.
Yeah, exactly.
Oh, wonderful.
Yeah, welcome to an old language.
Oh, boy.
Yeah, somebody decided a long time ago that was the convention, which is why I call it out, that it's a weird behavior. So the conditioning system. So I said that the messaging system is sitting on top of the conditioning system. So who here is familiar with error handling systems in other languages like Python and C? And just one of you. Oh, okay. Two of you. Okay. So most other languages, the way they work is that when an error occurs, that the call stack, like what function called what function, what called what function, that collapses back up until you have a handler that handles it. And R technically doesn't work that way. R has an extra component to it. It has a signal and a handler, and then what the other programming languages don't have is a restart. The only other language that I know that has a restart is Lisp, and if you hate it yourself and learn Lisp at some point like I did, then R has a lot of Lisp-like behaviors in it. So the advantage of the restart is that you can get your code to restart where the error actually occurred, but the logic for what to do is actually higher up in the call stack. So I'm going to sort of gloss over those details and just sort of show you the way that I see most people using R, which is this TryCatch, where you have an error and the call stack collapses back up until something can handle it. So again, we have a signaler, a handler, and a restart. So a signaler says, hey, pay attention to me. So message is the signaler. And then the handler is something that's going to handle that message that it's going to get. And then restart says, you can go ahead and re-execute the code where the error actually occurred, where the signal was actually sent. So it keeps track of that. So the signaler is a method that raises or throws the exception object. So there's this object called a condition, whether it's a message, a warning, a stop, error, or something that you completely make up, there's this object called condition. And as long as you inherit that condition, then it's an S3 object. And then the system just handles that and knows how to pass that through your call stack for you. The handler tries to catch the condition, and the handler is specific to the type of message that you have. So you would have a handler for message and a handler for warning, or if you want to have a handler for John and you're throwing a condition John, you can do that too. So the basic way that this would run is that you have your system running and it calls main. And then main is going to head and call method A. And then method A is going to head and calls method B. So we're now down main, method A, method B into the call stack. Method B decides it's going to throw an exception. So it's going to print a message, it's going to call stop, it's going to call a condition John, whatever you want it to be. So method B then passes that back up to method A. You don't have to do anything in your code. This is all handled by the framework by itself. In method A, if there is a handler, it will handle it. If not, it passes it back up to main, and main will handle it if it has a handler. At that point, you can do whatever you want to do. I'm going to show you some very, very simple things to do with it. You can handle it, and then you can do what's called a restart. And what that would cause is method B has not collapsed like in other programming languages. Method B still exists, and you can go back to method B and do a retry. So like, hey, this code failed. Like I was expecting an integer, and it came back as a character. And the main says, oh, just convert that character to a number. Do your best. Passes it back to method B, and then it reruns the code from there. So that's how the system actually works. Almost nobody writing R code does that. Everybody does this standard programming paradigm called a TryCatch. So in a TryCatch, what you're going to do is you're going to try to run some code, and if it fails, you're going to have another block of code that's going to catch it and handle the error. So the expression is called TryCatch. It's a function call, and then I have written their expression. Expression is a block of code. So we're going to put squiggly brackets, and we're going to put whatever we want in there. We put hundreds of lines of code in there if we want. But technically, that's just one parameter being passed into the function. And this is handled very easily in R because functions are first-class objects. It's just like an integer. It deals with it no problem. And then we're going to have condition class 1, condition class 2. So these are the handlers that we're going to have. So condition class 1 may be message. Condition class 2 may be warning. And so if it gets an object of message type, then it's going to call the function that's attached to the message method. I'll show you some examples of that so it's a little less abstract. I just want to show you the syntax. So here we have a function. I'm going to create a function that's going to add. So I'm going to use the percent plus percent, so that's defining a function, and it's going to take a left-hand argument and a right-hand argument. And it's going to check to see if the left hand is an integer and that the right hand is an integer, and If it's not, then it's going to throw in a stop message, it's going to throw an error. So if that works, then we're going to actually add the two numbers and return back the result. So that's my definition of the function that I'm going to have my error message in. So I call TryCatch, and then I'm saying 5L, which means make it a 5 integer, not a 5 numerical value. And then the plus operation, and then 4L. So I'm adding 5 and 4 together, right? And now I have my condition, error condition 1, which is called error. And it's going to have a function. And so it says function E. So E is the error object that's going to get thrown. And it's going to just do something very, very simple and stupid. It's just going to return a 0. So if I call this, there is no error handle being called here, because I'm passing in 5 as an integer, 4 as an integer. It checks in the function, is it an integer, is it an integer? Yes, yes, no problem. It doesn't call stop, it adds them together and returns back a 9.
But your stop statement should be, parameters must be integer, not numeric, right?
Yeah,
Okay.
good catch. So now this is the same function. I haven't changed anything other than what's in the TryCatch. So here I have 5 as an integer and 4 as a numeric. So now the stop is going to get called because the 4 is not an integer. So what happens is the stop function throws a condition called error. And then in my TryCatch, I have error equals. So if I get the condition error, then I want you to call the function that's written to the right-hand side. And all that's going to do is return back a 0. I can have it do anything I want. I just wanted something really simple. So in this particular case, when I say 5 plus 4, it comes back with 0. But no warning message, no error message. My code grabbed the error, dealt with it, and the code program kept going on. Right? It's a bit of a nonsensical example, right? It's 5 plus 4 is not 0. But that's how I decided to have my code happen. I didn't stop. I called stop, but my code didn't stop. The signaling system captured the error, dealt with it, and said I'm just going to return back a 0. That's the logic I'm using. Did I lose anybody on that?
So, John?
Yep.
You can technically put whatever you want and
Whatever I
say stop,
want.
and it won't even get sent to standard error or anything like that?
Correct. What happens with stop is it throws the condition, and at the very top of the R call stack, there is a default handler that says, take whatever that message is and write that out to standard error. So there is actually a handler there. I'm just overriding the handler that's in there. So here we have a TryCatch, and there's a no warning handler. So I'm going to pass in 5 and 4, where the 5 is an integer, and it's going to call is double on the right-hand side, converts it to an integer, and says, hey, just to let you know, I was expecting an integer, but you didn't give me an integer, but I was able to convert it for you. I'm just going to give you a warning and let you know. And this is a good practice to be putting into your R code, because R is not really type specific. You can pass it pretty much whatever you want, and it just kind of works half the time. So you'll commonly see this in some of the base R functions where, like, if you pass it a vector, it only looks at the first one, so like equals. If you pass it a vector, it will just say, like, hey, the first one is, I'm only checking the first one, I'm not checking all of the vector. So you should give me a warning, because there may be things in there that's not behaving the way you think it is because you didn't call the function right. So here I'm just doing that. I'm handling the error by casting it and then just throwing a warning. And then, if you notice, I don't have on TryCatch, I don't have a warning handler. So the warning actually gets displayed. So if I want to suppress that warning in the TryCatch, I could go warning equals and then do some function. Or I could have called suppress warnings around the whole function. So in this case, the sum is computed and returned, whereas the other one I just had it return 0. And then there is a finally. So finally is part of the TryCatch. It's another parameter that you can pass in, and you can run any arbitrary code you want. And finally will get called anytime that a condition signal is sent. So if you call message, warning, stop, or any other condition that you want to throw, it will run that finally code. If no condition message was sent, then finally won't actually run. So this is really handy if you're doing, like, say, file operations, and you open a file and you're writing something, and then if something happens, you don't want that file to exist because that file is effectively corrupted in your use case. So you can just have finally, like, delete the file or close the file, whatever you want to do, so that you can you can handle your error condition in a state that's nice and safe. So what I just showed you was basically the way you would use this in other programming languages like Java and Python and stuff like that, where you have this try-catch and everything is rolling up to that try-catch. So all the functions underneath, even though I was only showing one layer deep, get collapsed up, and you don't have the ability to run code in them anymore. Like, I couldn't run code in my plus function the way that I've done this with try-catch. There is a method called with handlers.
With calling handlers?
With calling handlers, thank you. That's the problem of autocomplete, right? With calling handlers that will allow you to then re-execute or restart. So you could go back into that function and you can re-perform some operation that you wanted by changing your business logic. So what it allows you to do is it allows you to write your code so that your underlying code is abstracted away from the business logic that you want to do, and then the business logic up above can handle that and tell it to do different things under different certain conditions where that code may not have actually had the full knowledge of what's going on in the big system, because it's just a small sub-portion of it.